Hey, what's going on, everybody? About to make you a quick word problems video. The other classes did this same stuff yesterday, so make sure that if you did not understand it as the video goes along, one, you rewatch it. Secondly, you can actually go and talk to somebody else in a different class. The printouts of this page are at the front of the room on the podium already, so hopefully you can go and grab one. If not, go ahead and pull it down off a Blackboard. I'm going to go ahead and get started by talking about the first problem. First problem says that Danielle buys 6 shirts, 3 pairs of shoes, and spends $300. All I want you to do with that first sentence is write an equation. You have $300. That has to be the total. Now, what I'm telling you is that she bought 6 shirts and 3 pair of shoes. I'm going to label them with X and Y. Adding them together, that's how I get 300. Now you're trying to figure out, all right, well, where do X and Y come from? You never defined the variable. That's right. So defining the variable, and this is the hard part of the process, is just telling your audience what these letters actually mean. So I'm going to let X equals the cost per shirt. That means Y is going to equal the cost per shoe. So I took the first equation, 6 shirts, 3 pair of shoes, added up to 300. Now I'm looking at the second sentence, talking about Aaron. Aaron buys 1 pair of shoes and 5 shirts. Make sure that now that you have defined your variable, you match them up. The 1 pair of shoes should go with the Y. The 5 shirts goes with the X. Total is 145. At this point, you should know how to solve this equation, this system of equations. I don't care if you use substitution or if you choose to use elimination. They both work. So what I'm going to do is I'm going to show you the substitution. When you look at the answer key online, the answer key is actually written out in elimination. Both of them work. You get the same answer regardless, but this process says get one variable by itself and plug it in. That process ends up with 6x plus 3 times all of that stuff I put in the first box equals 300. When you go ahead and solve this all the way out, you should end up with an answer for per shirt is 15. The answer for per shoe is 70. Last thing that I want you guys to do is, it's a good habit to get into, is make sure that you label your answers with a $sign, please. If you want to see the work all the way done out, you need to go ahead and check the answer key online. I don't have time to go through that right now. So right now, I'm going to go ahead and pause the video, scroll down to the next screen, and get ready to do the next problem. Alright, now, I'm talking about Juanita and Kathy. Juanita and Kathy start running at different times. Juanita starts first going 5 miles per hour. Kathy starts an hour and a half later, aka 90 minutes, aka 1.5 hours, 3/2 hours, but runs at a rate of 17 miles per 3 hours. How long has Juanita been running when Kathy finally catches up? And then I also ask you a second question here, and that's what is the distance? Alright, first thing that should pop into your head when you see miles per hour is that is a rate. Miles per hour automatically should translate in your head to being y equals mx plus b. So we're going to try to set these two things up with y equals mx plus b. And to do that, I'm going to make a t-chart. You remember t-charts from way back in the 3rd chapter of the school year? I'm talking about Juanita on this first one. She starts at 0, 0. She's going 5 miles in 1 hour. So if I want to turn this all into an equation now, Notice this is plus 5 and plus 1. I'm going to plug everything straight into my equation. It says y equals my slope, 5 over 1, times x minus 0 plus 0. Of course you don't need those actual zeros, but let me remind you where they came from. The first 0 goes on the outside, and the one from the y column went on the inside. Go ahead and simplify that down one time. You should end up with y equals 5x only. That is for Juanita. My girl Juanita. Second equation, doing the same exact idea with making a t-chart, x and y. But notice, Kathy did not start at the same time. She did not start with her time equal to 0. She started with her time equal to 90 minutes, or 1.5 hours. The distance did start at 0 still. Her rate is 17 miles over 3 hours. So notice, here's your slope, plus 17 plus 3. Fill it into your formula. Y equals 17 over 3. In parentheses, you should have x minus 1.5. Still adding 0 to it. Now again, the 0 came from your y column, and the 1.5 was where you started with x. When you multiply this out, and I'm going to go ahead and turn it into a fraction at the same time, just because I like fractions a little bit better than I like decimals, might end up with an equation for Kathy. And Kathy's equation says y equals 17 over 3 x minus 51 over 6. Now, if you're somebody who noticed that 51 over 6 can also be reduced, good for you. If you go ahead and reduce that, it turns into 17 over 2. Now, I ask you the question, how long is it before they catch up? How long has it been when Kathy finally catches up? In other words, I want you to take these two equations and make them equal to each other. So scrolling down just to give myself a little bit more space to work with here, I'm taking my first equation, my equation for Kathy, my equation for Juanita, setting it equal to my equation for Kathy. So now it says 5x equals 17 over 3x minus 17 over 2. Go ahead and use a 6 to multiply everything all together. That way you have no denominators at all. 30x equals 34x minus 51. Solving it all the way out, you end up with two answers. The first one says that x equals 51 over 4. And your second answer for y, you're taking your 51 over 4, plugging it in. So take this answer, plug it in where? Well, I would probably just take it and plug it in right here to the 5x. In other words, taking 5 times 51 over 4, your final answer should be 205 over 4. Now again, do me a favor, remember to label your answers. 51 over 4 is hours. 205 over 4 is miles. Again, I'm going to pause the video right now, give you a chance to catch up. Remember, answers for this are online. The video itself is going to be posted to Blackboard as well. Alright, so notice I just skipped from the second problem to the fourth. The reason why I'm doing that is because I don't want to run out of time without actually showing you how to work through a mixture problem. It says Katie mixes 2 flavors of Arnold Palmer together. You know what an Arnold Palmer is. You know that it's half lemonade, half iced tea. Now hers is actually not the right ratio. She has one mixture that's 50% lemonade and the other mixture is 33%. If the resulting Arnold Palmer, once she mixes everything together, she's going to have 20 gallons. And the new solution, the new Arnold Palmer, is going to have 40% lemonade. So I want to know how much of each mix does she actually have. First thing I want you to do is I want you to label your variables. I'm going to let X equal mix 1. I'm going to say Y equals mix 2. And again, this is so that you can keep your work a little bit more organized, so if somebody just walks in and picks up your paper, they actually know what's going on. First equation, I just want to know how much lemonade you made. I want to know how much lemonade you're going to be using. How much the total amount is from each one of these mixes. It has to add up to be 20 gallons. There's nothing else happening. If you add the first mix and the second mix, then you're going to have 20 gallons. Call that the count. Now in the second one, I need you to involve the value this time. And the value in this particular problem is the percentage. We don't like writing percentages as 50. 50% is really a decimal. How about 0.50x? And attach that straight to the count equation. I'm going to attach the 33% straight to the equation I had before. I'm going to attach this 40% right onto the side of my 20. So now I have two separate equations. And I know a lot of you guys are like, but I don't know how to deal with that because it has decimals in it. How do I get rid of the decimals? Can I do it like I did fractions? You're supposed to know these two decimals. If you don't know those two decimals, then we have a bigger issue. You are required to know that 1/2 is the same thing as 50%. So this problem should say 1/2 x on the bottom. You're required to know that 1/3 is the same thing as 0.33333333 repeating. You have to know that. If you pull out your phone or your calculator right now, 40% of 20 is 8. Do you know how to solve this? Yes. The answer to that statement is yes. You do know how to solve this. So you would either use elimination or substitution. Whichever one you choose, you end up with the same answers again. So go ahead and do that yourself. Your answer should end up being 8 gallons of the first mix and 12 gallons of the second. Now again, the actual solution written all the way out is listed on Blackboard for you. All you need to do is go and check it yourself. You know how to find all that material. In addition to that material, your review materials for your final exam are on there. So the last problem, the one that I skipped earlier, is the hardest possible problem that you could have this year. It says if train A left at noon and travels at 250 miles per hour, then train B leaves at 3 p.m. traveling at 175, what time will the trains be 1,500 miles apart? So what I'm going to do is I'm going to make two T-charts. The first one for train A has an X and a Y. Same thing as what we did before. It's time and distance. So after 1 hour, the distance went from 0 to 250. On my other T-chart, it didn't start at 0 this time. That's the big difference. It started off at the same train station at 0. It went 175 miles per hour. But notice, it started at 3 o'clock instead of at noon. So starting at 3 o'clock, you need to change that. You're going to end up with two equations. If you go ahead and fill it out the same way that we did last time, you're going to end up with the equation that says y equals 175x minus 525 for train B. Train A is going to be y equals 250x. So the last thing that you need to do on this problem is actually add your two equations together and say it has to equal 1,500. That's how far apart they're going to be.